Hello students, in the previous class we have seen the Bohr's demerits, merits. Let us discuss about today quantum mechanical considerations, subatomic particles. So in this generally Bohr's had described different models of atoms. In that, two important developments which contributed significantly. Such models are here: dual behavior of matter, that is Deborglies theory, and Heisenberg's uncertainty principle. Next, let us see about here Deborglies theory. Our first model is here. Deborglies theory, that is dual behavior of matter. This is the first model he has discussed. So here Deborglies means dual behavior means what? We are having both wave nature and particle nature. Yes or no? So coming to here Deborglies theory. Here Louis de Broglie, he is a scientist. He suggested that electron has wave character. And coming to two more scientists, Davison and Germer, prove that electrons have wave character by diffracting a beam of electron using nickel crystal as a diffraction grating. Okay, so coming to here, what he had told here, what is the dual behavior? So what he had told, Louis de Broglie suggested that electron has wave character. What he had told, for the electron it is having wave character. And coming to two scientists, one more two scientists, that is Davison and Germer. What they have proved? They have proved that electrons have wave character. They also said that wave character, but how the wave character will be? By diffracting a beam of electrons, means some light is inserting by using a nickel crystal. Okay, that one we call it as what? Diffraction grating. So means what here? By diffracting a beam of electrons using a nickel crystal as a diffraction grating. So here diffraction grating I am saying. So this is a grating, a thick line which is for example some light is passing. So to this slit some grating will be having which is perpendicular. At the ends we are having some grating, that one we call it as grating. So diffraction is nothing but lies which will be visible. Okay, so this is nothing but diffraction grating. So according to de Broglie, any moving material particle means if anything material is moving that has wave character. Okay, these waves are called matter waves, we can say. So what he had, according to de Broglie scientist, what we had told that any moving particle has wave character. Okay, any moving particle has wave character. These waves are called as what here? These waves are called matter waves, we can say. So here then what will be having the wavelength of matter? We can say matter means we can take solid, gas, liquids or atoms, ions, molecules, anything we can take. Matter is nothing but. So means the space which is occupied. Here see the wavelength of matter. So then the equation we can give here for matter waves. Generally wavelength is denoted by lambda. Okay. So here the equation for this is h by mu, where h is Planck's constant. Okay. h by p. Okay. So p is nothing but momentum of the particle. So where h is a Planck's constant. So what is h? Planck's constant. P is nothing but momentum of the particle, where lambda we call it as wavelength of the Deborglies atom. So then what are the objects we can take here? So this is nothing but equation. This is a Deborglies equation. So here for objects like rifle bullet, cricket ball. If you take cricket ball, when you it will be moving, yes or no? Means it can also give wave. But here the wavelength is, for this type of items, the wavelength is very small. Okay, so they appear as what here? Particle. Okay, so generally according to first Bohr's orbit, the wavelength of electron here is, the wavelength of the electron in the first Bohr's orbit, what we can say? The first Bohr orbit is 3.33 angstroms we can say. Okay, so generally here the electrons, which is an atom. Okay, in an atom what happen in standing wave is a standing wave we can say, which is extended over a circumference whose circumference is equals to integral number of wavelength we can say. Otherwise the electrons wave destroys itself by destructive interference. Suppose if the wave is not correctly standing, means the electron will destroy. So by this what we can say means here the electron in an atom is a standing wave extending over a circle whose circumference is equals to an integral multiple of otherwise the electron wave destroys itself by destructive interference we can say. Okay, so means what here, by what we can say circumference of the orbit, what we can write here, circumference of an orbit we can say here 2 pi r, yes or no, in the circle, which is equals to n lambda. What is this meeting? The electron of an atom is a standardizing wave which is over circle whose circumference is equals to the integral multiple of wavelength. Means the circumference of a circle is equals to 2 pi r is equals to n lambda. So where r is equals to radius of the orbit we can say. and n is equals to number of integers, that is 1, 2, 3, 4, 5, so on. So here the number of electron waves or wavelengths in any orbit is equals to the principal quantum number, we can say. So what is this? The number of electrons electron waves or wavelength, we can say, of any orbit is equals to what? Principal quantum number, we can say. Okay, so this is nothing but quantum number small n. So this is nothing but what, Amma? This is nothing but one of the model, that is Deborglies theorem, which can say about only particles, means the moving particle, we can say. It can show any type of waves and also electrons. Electrons can also show wave character, the particle nature. In the same way, this is nothing but dual behavior. And the next one is, we can say here, Heisenberg uncertainty principle. Heisenberg's uncertainty principle. Okay, so what he had told, the position and momentum of an electron cannot be determined same, okay, at the same time, and also at the correctly we cannot determine. So what he had told, it states that the position and momentum of an electron, the position and momentum of an electron cannot be determined simultaneously and accurately. Means what here? The whatever momentum of an electron, means the moving electron and also the position where the electron cannot be determined at the same time and also correct time. That one was stated by Heisenberg uncertainty principle. So then what is uncertainty principle is nothing but here the product of uncertainty in position and momentum of electron, uncertainty in position and momentum of electron is equal or greater than h by 4 pi. So means whatever position or the electron we are taking, means the product. So this is the delta x electron delta p, means the product means multiple, delta x dot delta p is greater than or equals to what here? H by 4 pi, we can say. So where delta x is nothing but what? Uncertainty in position of electron, delta p is nothing but uncertainty in momentum. So the position and momentum of the electron will be greater than or equals to h by, where delta x is equals to position and delta p is equals to what here? Uncertainty in momentum. Okay, so by this what we can write? Delta p is equals to, as we know, m delta v. Okay, so the above expression can be written as like this. This expression can be written as like this also, delta x dot m delta v greater than or equals to h by 4 pi, where delta v what here? Uncertainty in velocity. So generally Bohr's postulates of fixed orbits is not in agreement with Heisenberg uncertainty principle, we can say. Why? Because what Bohr's postulates of fixed orbit is not in agreement with Heisenberg's uncertainty principle. Why he is not agreement with uncertainty principle means here the position and movement of electron we are speaking, but Bose cannot speak like that. So this uncertainty principle applies only to subatomic particles, okay, like the electron, but not to the microscopic bodies like a cricket ball, which Deborglies has explained. So what happens? The uncertainty principle applies only to subatomic particles, okay. Like the electron, means he can explain about only electron but not to macroscopic body, means large items like a cricket ball. So this is nothing but uncertainty principle. Coming to Deborglies theory, what he had explained, he explained about a wave nature. Coming to here uncertainty principle, he explained about a particle, okay. So this is nothing but the Deborglies theory and uncertainty Heisenberg uncertainty principle. These are the two models which have developed by the Bohr's theory, okay. Next.